Assalamualaikum and hello everyone. Welcome to the video for 2.2 Calorimetry, where in this video we will learn to define heat capacity and standard heat capacity, actually here specific, and then calculate the heat change in a constant volume calorimeter and calculate the heat change in a constant pressure calorimeter. Okay, so without further ado, let's do the definition. Okay. Heat capacity, or capital C, is the amount of heat required to raise the temperature of a given quantity of the substance by 1 degree Celsius. So when we're talking about amount of heat, which is our energy, so we measure it by the unit of joule. And when we're talking about raise the temperature by 1 degree Celsius, so it will be per degree Celsius. Okay. What about the specific heat capacity, or our small c? It is the amount of heat required, again, to raise the temperature, but for the specific one, here we have specific mass of the substance, which is 1 gram of the substance, again by 1 degree Celsius. So instead of the unit joule per degree Celsius, for the specific, kita ada specific lagi per gram. Okay, so next what we're going to look at, okay, so that is the definition. Next, so the name of our subtopic itself is calorimetry. So what is the calorimetry? So here it mentioned that calorimetry is a method used in the laboratory to measure the heat change of the reaction. Okay, sometimes we can determine the amount of heat ni, the heat capacity and specific capacity ni by using the calorimetry method because it is used to measure the heat change. Okay, and then apparatus used in the calorimetry is known as the calorimeter. Okay. So, for calorimeter, it is divided into two. We have a simple calorimeter, which is actually a calorimeter using a styrofoam cup, and a bomb calorimeter. Okay, so actually, our experiment tool later is using our styrofoam cup itself. Okay, for the simple calorimeter, it mentioned that it is suitable for measuring enthalpy change that take place in the aqueous solution, namely enthalpy of neutralization, where it is used to measure the heat flow in a solution. Okay, for the reaction of neutralization, we know that acid plus base, we will get water, and we will have our aqueous solution lah. Okay, so for this reaction, actually we will form our water and the solution itself. So for the simple calorimeter, can be used to measure the heat flow in our solution. Our solution is from H2O plus our water. Okay, and then here it mentioned that heat released by the reaction. Okay, again, neutralization is a process where heat is released. Okay, so here it mentioned that the heat released by the reaction is absorbed by the solution and the calorimeter. Okay, for a reaction to occur, okay, so we assume our reaction to is actually our system lah, reaction to system. So when our system, when there is a reaction from our system tu, dia akan release heat. Dia akan release heat to the surrounding. So dalam case simple calorimeter, the surrounding will be our solution and the calorimeter itself. Okay, so that is for simple calorimeter. For bomb calorimeter, it is used to determine enthalpies of combustion, and it is used to measure heat flow for gases. So for simple calorimeter, only for solution. Bomb calorimeter, only for gas. Okay, so here it mentioned, for the bomb calorimeter, we do have one without water, one with water. Okay, so when using a bomb calorimeter with water, again, when we're doing combustion, heat is released. Heat is released by the system. When heat is released by the system, surrounding must absorb the heat. Okay, so here it mentioned that heat release is absorbed by both the water and the metal parts of the calorimeter. So for example, here, okay, if for the combustion without the water, okay, combustion from the system itself, okay, heat is absorbed by the surrounding kita only calorimeter. In this case, with water, our surrounding is not only our calorimeter, we also have our water. Okay, so that is the type of calorimeter. Next, here it mentioned the basic principle of calorimeter is that the heat released by the reaction must be equal to heat absorbed by surrounding. Okay, so that's why it is important for you to be able to identify what is the type of surrounding based on the question. Usually, sekarang nampak macam mana nak tahu? Okay, later we will look at the examples itself. Okay, so for the heat released by the reaction, we cannot calculate it straight away, but we know it is equal to heat absorbed by the surrounding. So we can calculate it by the heat absorbed. Okay, so that's why it's important to know what is the surrounding. So let's look here. Okay, first surrounding is when is calorimeter. When the heat absorbed is through calorimeter itself. Okay, so Q is our heat release. Okay, equal to heat absorbed by the surrounding. Okay, here it seems like a lot of letters kan. Senang nak ingat dia adalah MCAT or CAT itself. Ini capital C lah. It must be capital C. Okay, so MCAT. M stands for mass. Here I'm mass. C is your specific heat capacity. Okay, delta T, yang CAT tu, yang at tu is actually delta T itself. Okay, and then if the letter is capital C is your heat capacity lah. Okay, so but then kenapa kat sini C? Okay, C denote for our calorimeter. So for the calorimeter, it could be MCAT or our CAT itself lah. Okay, how about the surrounding is water? Okay, we will use Q is equal to MCAT, but then M and C must be W. For the case of water, we will always use MCAT, never CAT. Sebab from the question itself, usually dia akan bagilah specific heat capacity and the mass of water. So for water, it will always be MCAT. And last but not least is if the surrounding is calorimeter and water. So, contohnya first example, it could be MCAT plus MCAT. Pening ni miss MCAT. Make sure lah. Kalau here mass of water, here pun must be specific capacity of water. Here calorimeter, here pun must be calorimeter. Or sometimes, kalau the information given is the heat capacity of calorimeter, so kita boleh guna MCAT plus CAT. MCAT ni must be always be our water. CAT tu tengoklah calorimeter dah bagi, so that is our CAT. Okay, basically this topic inilah formula kamu ingat MCAT, CAT. Tapi yang mana satu kita nak guna, we have to look at the question itself. No worries. Okay, so here is all the formula. Okay, so the formula is to find out my Q. When we're talking about the calorimeter, dia kata we can find out the enthalpy of neutralization or combustion kan. So how do we measure the enthalpy or delta H? Is that we will calculate the heat released by the reaction divided by number of mole. Okay, for example, kalau combustion, the number of mole what we are combusting lah. For example, kalau C2H2 ke yang kita combust, ataupun kalau neutralization, it will be NH2O. Okay, so dah macam banyak ni introduction ni. Introduction berapa minit dah. Next, what we're going to look at is the examples itself to do the calculation. Okay, so here is example number 1. So here are the formula that I've written down beforehand. Okay, so let's look here. Question number 1. How much energy is required to heat a styrofoam cup from 28 degrees Celsius to 35 degrees Celsius if the heat capacity is 46.8? So from here, we know that this is my initial temperature. This is my final temperature. Okay, heat capacity is capital C. Okay, so from here, which one we're going to use? Is it MCAT? No, we cannot use it. So we're going to use Q is equal to CAT. But then again, here we do not know heat capacity of what? Sebenarnya heat capacity of our styrofoam cup, which is our calorimeter. So here is actually CC. So we will use Q equal to CAT and we will substitute the value. But before that, what I'm going to write down is actually I'm going to extract the information first. So when we extract information, actually from here we know lah this is my delta T. Where final, for delta T must be final minus initial. Okay, because temperature will always, for this case, we will take it always a positive value. So final minus initial, again, because this is actually about combustion or neutralization, it means heat is released. So temperature final must be the highest, the higher one. Okay, so we're going to substitute the value into Q is equal to CAT. Hence, we will get this value. Tada! Kind of straightforward sahaja. Okay, this is the type yang straightforward. Introduction only. Okay, so that's for question number 1. Next is actually for question number 2. So, question number 2. Okay, calculate the amount of heat released in a reaction in aluminium calorimeter with a mass of this. So, mass of our aluminium calorimeter. So, here will be my MC. Okay, and contains 1,700 ml of water. Okay, so again, this is mil. Okay, mil is actually my volume. Okay, kalau mass, actually, punya unit is actually gram. So here, jangan tulis dulu MW. just write down it as VW, volume of water. Okay, the initial temperature is 25 degrees Celsius, T1, and it increased to 27.8. So increased to 27.8. So here is my temperature final. Okay, given that specific heat capacity of aluminium is my C, okay, specific heat capacity of water. So here is my CW, and water density. So here is my density of water. Okay, so what I'm going to do is actually I'm going to extract all the information first. So from here, as we can see, for MC and CC, we have MC and CC. So we know that it must be involving MCAT for calorimeter. Okay, but then for the water itself, we have our CW. Okay, but then we do not have our MW. We do not have CW ada, MW tak ada. But we only have our volume of water. Okay, remember that for the formula of density, density is mass over volume. Since the density of water is equal to 1, mass over volume, so for the case of water, mass is equal to volume. So, starting from now, when you look at the question itself, it gives to you the volume of water. So, we can assume straight away that the volume of water is equal to the mass of water. So, I'm just going to write down. So from here, and I also have calculated the delta T. So I have my MW, I have my CW, I have my delta T, and then I have my MC and CC. So which formula that we're going to use? The last one here. So this is the answer that you will get when you substitute the value straight away. Okay, remember that for Q, the unit will be joule. Okay, but then if the question does not specifically ask you to write down in kilojoule, it's up to you lah. But then it's either 24680 joule, or you want to change it to kilojoule, so you have to divide it by 1000. But again, Q will the unit for it is it will be joule itself. Okay, so for this case, okay, so that's why for me, it's up to you whether you want to understand it in terms of surrounding, or sometimes it's actually depends on the question. What does the question give you? So you determine lah which formula will be used. But sometimes the tricky part later we're gonna see. Certain dia tak bagi CW ni. It does not give you the CW. But then it give you the mass. Okay, why? Because actually for the CW, it is given on your list of constant. Specific heat of water. Here we're talking about 4.18 joule per gram per degree Celsius. So if the question does not give it to you, tapi dia bagi mass of water, so you can take it from here lah, from your list of constant. Later I'm going to remind you again. Okay, so that is for question 2. Okay, next is actually question number 3. Okay, so for question number 3, okay, here it mentioned when 0.02 mole octane. So yang ini tiba, okay, write down je. Number of mole is C8H18 is 0.02 mole. Oh, lah. Okay, was burned in a calorimeter, the temperature of 1000 ml water. So again, when you write down 1000 ml water, so kita akan assume we're going to take straight away. This is mass of water kita lah. Nanti kita kan ni as gram. Okay. Increase by 24 degrees Celsius. So increase by 24 degrees Celsius. So here it have give to you the delta T. Okay. Previously the question only give it to you macam the temperature increase from 28 to 35, or in this case from 25 increase to 27.8. Okay. But this case it already mentioned specifically increase by 24.2 degrees Celsius. Okay. So here it mentioned what is the enthalpy of combustion of octane. Okay, given that this is my CW and this is my density of water. Again, density of water too, so that we know that the volume of water is equal to mass of water. Okay, so what I'm going to write down is actually I'm going to extract the information first. Okay, so this is all the information. Okay, what's in here? Okay, what is again the question? The question here, what is the enthalpy of combustion? So enthalpy of combustion is our delta H. So this is actually the formula I've written down in front. Delta H is equal to Q divided by N. Okay, so for this question, okay, how to answer it? Okay, to determine the enthalpy, we have to find the heat release dulu, then we're going to find out the number of mole. Okay, in this case, we're talking about the combustion. Okay, combustion of what? So, combustion of octane. So, the formula will be, I'm just going to write down at the side here, delta HC is equal to my octane C8H18 is equal to heat release. Number of mole ni must be the number of mole of our octane itself. Okay, sekarang ni what we're going to find out is my Q. Okay, Q ni is actually, again, depends. Look what is the information given. MCAT, CAT ataupun MCAT plus CAT. Okay, so based upon the information, what we have here is actually MW and CW and delta T. Do we have any information about calorimeter? There's none. Okay, information ini sebab kita nak bagi tahu tadi the volume is equal to mass. Ni number of mole ni nak guna bila? Okay, tu nanti. Again, we are interested in kalau water dan calorimeter je. Yang ni kan octane kan? Tak nak. Okay, so which formula we're going to use? Q is equal to MCAT. And we will substitute all the values. Okay, so this is the value once I substitute it. Okay, so this is my Q. Okay, done finding out my Q. Okay, next is the number of mole. Again, because we want to find out the enthalpy of combustion, heat done. Next is number of mole. Okay, for the number of mole of octane is given in the question itself, 0.02 mole, 0.02 mole. So what we're going to do is actually, we will substitute the value straight away. Q is actually this one. The number of mole is 0.02. We do get this value. Okay. Okay, why do we get this value? But then the answer is this one kan? Okay, tapi tak apa, tengok dulu. Okay. Again, for this case, the unit of Q is joule. The unit for number of mole is mole. So unit area will be joule per mole. Okay. But then again, because it does not specifically mention in kilojoule per mole, so we can left it here, or we could write down the answer as 5057 kilojoule per mole. But then that is not the end of the question yet. Okay, so sebenarnya dekat jawapan sini, Miss sendiri yang terlupa letak. Sebenarnya kat sini semua mesti ada negative value. Okay, why do we have negative value? Sedangkan Q dengan N is a positive value. So it is impossible to get a negative value kan? Okay, this is because, again, enthalpy of combustion is actually heat release. So when heat release, we have to include the negative sign. So this is the thing that we have to manually add in. Tak negative sini ataupun sini. Okay, you have to add in yourself because to show that the heat is released. Again, bila kamu bakar something mild, rasa sejuk, mesti rasa panas. So you have to add in yourself. Okay, so it's quite a lot of steps. Again, untuk Q ni, we have to look based upon the information given. Okay, next, supaya kamu tak confused, okay, either ni kan octane ni kan, kena masukkan ke dalam MCAT tu. So that's why it's important for you to write down yang H is equal to Q divided by N. Write down the N to what is the N used for the reaction itself. Supaya kamu tak confused. Okay, just a bit. Okay, for example 4, I believe you could try yourself. It's just that for this question, it mentioned that a bomb calorimeter has a heat capacity with a 0.26 gram sample of acetylene was combusted. Here it mentioned determine the energy required to burn 1 mole of acetylene. Okay. Here it mentioned about burn 1 mole, so here is about combustion. And when it is actually talking about 1 mole of our reactant here is actually our standard enthalpy of combustion. Okay, again, for delta H, this is actually about our C2H2. So again, Q divided by N, where N must be C2H2. So here, for you not to get confused, but for example, in this question itself, C2H2 is given in terms of mass. So dekat sini kan takut kamu confused, MCAT, CAT ke, mana satu ni, mana satu. So that's why it is important for you to write down the delta H dulu. Because then you can see when we're talking about mass here, we do not calculate in terms of our Q, we will calculate in terms of delta H. Again, the value will be a positive one. The negative you have to add in yourself. Okay, the same goes for question number 5 and 6. Okay, again, I have written down beforehand. Number 5, the combustion of xylose. So here, number of mole of xylose. Here is it also give to you the mass of xylose. Again, the mass of xylose is used to calculate the M. Okay. For your Q equal to MCAT must be always is either your water ataupun calorimeter sahaja. If other things, it is used for your number of mole. So here I've written down the same goes for number 7. Okay, negative, you have to add in yourself to show that the reaction is a combustion reaction, so heat is released. Okay, so that's it for this video.